Okay, let's get started with today's class. We will see a couple of more proofs and we will move on to Unit 5 today. Unit 5 will not be there on the test, but the first three slides, it's like the review of what we have done. So you should be able to work on them with me. Let's see the first slide. Okay, I want you all to use your chat and indicate whether the given pair of triangles is congruent by which postulate or theorem or not possible. Some may have more than one answer correct. Okay, use your chat and tell me which postulate you can say or which theorem you can use to say these triangles are congruent. First, second, and third, use your chat. I will give you like a minute. Okay, as majority of you answered, the first one is going to be, let's label this to make it simpler. You have an angle and then side and then angle. You have angle, side, angle. So you have A, S, A, congruency postulate. Okay, on this one, you have this one which is congruent to both of them, which is opposite to right angle. So this is H and this is your leg. So HL congruency postulate. Here once again for this triangle you have H and this is your L. So HL congruency postulate. And for these two triangles I have this side, angle and then side. We just observe triangle KPN. In that we have this as your side. And then at PA is the congruent angle, then we have this side. So SAS congruency postulate. Okay. All of you try problem 4, 5 and 6. Okay, you have another minute and then we will take a look at the answer. Fourth one is going to be your, so you got to label them accurately. You have this side, then you have an angle, and you know these are vertical angle pairs which are going to be congruent, then you have an angle. So it will follow a pattern of AAS. It won't follow a pattern of ASA or any of those. So it's going to be AAS. So you have AAS triangle congruency postulate. Angle, angle, side, triangle congruency postulate is the correct answer for the fourth one. It can't be HL this time because you have only one leg. They have not given this hypotenuse being congruent. On the fifth one, once again you have an angle, then they have not told any of the sides which are beside this angle. The next thing that we have is once again angle. Then we have a side. So it's the same. AAS. Just if you label one of the triangle, we'll get to know. You don't have to label both. AAS triangle congruency postulate. Then next, triangle DBC and triangle EFG. Once again, you have an angle, angle, and then you have a side. Angle, 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 and a side. So it's same angle, angle, side, triangle congruency postulate. Last couple of them. Use chat once again for last two and share your answers. We will check answer in 30 seconds. Well, I have answers from most of you. So here once again, if I just label, this is a common side which is going to be congruent to both the triangles. I have a side, side, and then side. So you just have only three sides. So SSS congruency postulate. Let's say over here I have this particular leg and this is your hypotenuse. So you have HL congruency postulate. I hope you are able to identify various postulates that can be used to prove that triangles are congruent in using these problems. Okay, let's see the next slide. Given DE is congruent to CE, let's mark that. Where is DE? DE is over here, is congruent to CE. And then angle ADE is congruent to angle BCE. Angle ADE is congruent to angle BCE. Prove that triangle AED is congruent to triangle BEC. Okay. Statements and reasons. Wherever I leave blank, please fill that using chat. Let's see the first one. First step is always whatever is given. So I'll just write DE is congruent to CE, comma, angle ADE is congruent to angle BCE. So that is given. The next step, angle ADE is your angle and this is your side. But I can have this particular angle congruent, right? Vertical angle pair. I can have these two angles congruent, that is angle AED and angle BEC. Use your chat for reason for this one. Angle AED is congruent to angle BEC. Fill up this blank and finally I can say that triangle AED is congruent to triangle BEC. Please use chat and indicate your answers for second and third step. I'll give you like 30 to 40 seconds. So these are vertical angle pairs. So by vertical angle pair postulate, you can say these two are congruent. So I'll just tell vertical angle pair postulate as the reason. And you have these two triangles congruent by ASA, triangle congruency. Triangle congruency postulate. Let's see the next slide. Given Wx is congruent to Yx, that's given, and Z is the midpoint of Wy, prove Wxy is congruent to triangle Wxy is congruent to triangle Yxz. So same way, I'll just write the statements and I want you all to help me with the reason. This is the last proof. After that, we will move on to the next unit. Wx is congruent to Yx and Z is the midpoint of Wy, which was given in the second step. Z is the midpoint of Wy. I can say Wz is congruent to Zy. Then I can say that Xz is congruent to Xz. Write the reasons for these two steps. And I can also say triangle WXZ is congruent to triangle YXZ. Okay. Use your chat and tell me the reasons for these three steps, and then we will see the next slide. If your friends suggested that WZ is congruent to ZY by definition of midpoint, that's absolutely right. By definition of midpoint, I can say that these two are congruent. And this is your reflexive property. Whenever you are speaking about the same side, it's your reflexive property. Reflexive property of congruent segment, if you want to be more accurate. Property of congruent segment. And finally, you will have these two triangles congruent by SSS triangle congruency postulate. Okay. Let's see the next slide. We are moving to the next unit. This is your unit 5 and we are starting 5.1, which is mid segments of a triangle. Okay, we are going to learn what are mid segments. Then we are going to see a mid segment theorem and see a few problems based on them today. A mid segment of a triangle is a segment that connects the midpoint of two sides of a triangle. Every triangle has three mid segments. Okay, a mid segment is nothing but it connects the midpoints of two sides of a triangle. For example, over here, if this is your triangle, A is the midpoint of HG and B is the midpoint of HJ, then AB is called as the one of the mid segment. Same way, if C is the midpoint of GJ then we can say that AC is the bit segment of this triangle, and as well as BC is also bit segment. There are totally 3 bit segments. Sometimes we mention all the 3, or we just use 1 or 2 of the bit segments. We don't have to use all the 3 bit segments. In some problems you may come across with 1 bit segment, with 2 bit segment, but the maximum bit segments that you can see in a triangle are 3, and they connect the midpoints of the sides of the triangle. Okay, let's see the next slide. The mid segment theorem. This is very important. Okay, all of you pay attention. The segment connecting the midpoints of 2 sides of a triangle is parallel to the third side and is half as long as the third side. Okay, if we have a triangle and D and E are the midpoints, if they are midpoint, then DB will be congruent to AD, BE will be congruent to EC. That's true by definition of midpoint. Apart from that, the mid-segment theorem states that whenever this happens, this line DE will be such that the length of this DE will be equal to half of AC. DE equals half of AC. Okay. And apart from that, we will also have DE parallel to AC. These are the 2 things that this particular bit segment will satisfy. One, that it will be half the length of this AC and it will be parallel to AC. Okay, I hope that is clear. We'll be using this extensively to solve problems today. So when the bit segment will be half the length of the opposite side which it is parallel to, and it will be parallel to that particular side. Okay, for example, in the previous slide, we will have AB is your bit segment. AB will be equal to half of this particular side GJ by bit segment theorem. Same way, BC will be equal to half of the opposite side, which is, so I'll have BC which is equal to half of GH. And AC which is equal to half of HJ. Okay, and apart from that, they will also be parallel. AB will be parallel to GJ and BC will be parallel to GH and AC will be parallel to HJ. Okay, this is what we can derive from the bit segment theorem if you apply on this particular triangle. Okay, let's see a few problems in the next slide. Okay, all of you use your chat and try to answer this. In triangle XYZ, XJ is congruent to JY. They have given XJ is congruent to JY, and YL is congruent to LZ, and XK is congruent to KZ. XK is congruent to KZ. Then, what is JK parallel to? XY parallel to, XY parallel to, and JL congruent to. Okay, use your chat and try to answer this 1, 2, 3 and 4. I will give exactly like a minute or so. Okay, use your chat to answer this. As your friend suggested, JK is going to be parallel to the opposite side, which is YZ, and XY is going to be parallel to LK, and JL is going to be congruent to XK and KZ. These two are congruent, and XK is half of XZ. JL is also half of XC. KZ is also half of XC. So therefore, JL is going to be congruent to XK and KZ. Same way, YJ is going to be congruent to JX and LK. Let's see the next two. We have JL parallel to XZ and JK congruent to YL and LZ. Which segments are the mid segments of the triangle? Because these are going to be, if these two are congruent, then J will act as the midpoint and same way L will act as the midpoint. So JL is one of the mid segments and LK is the other mid segment and JK is the other mid segment. So we will have JL, LK and KJ are the three mid segments. Okay, let's see the next slide. Use triangle GHG where ABC are midpoints of the sides. I'll solve the first one. I'll give you chance for the second. If AB equals 3x plus 8 and GJ equals 2x plus 24, what is AB? They are asking me that. If ABC are midpoint, then AB is a mid segment such that AB equals half of GJ. AB equals half of GJ from mid segment theorem. So I can write 3x plus 8 equals half of 2x plus 24. So you'll have 3x plus 8 equals 2x divided by 2 is x, 24 divided by 2 is 12. Okay. Further, subtract x on both sides and subtract 8 on both sides. That will give us 3x minus x is 2x and 12 minus 8 equals 4. And dividing by 2 I get x equals 2. Right? This is the value of x. But we are not just interested in x, we want the value of AB. AB equals 3 times of 2 plus 8, substituting x as 2. I have this equation. 3 times 2 is 6, 6 plus 8 is 14. So you say 14 units. Okay. Same way all of you try this problem. I'll give you like 30 to 40 seconds and then we will check the answer. Well, I have answers from your friends. So let's check those answers. We have AC equals half of HJ. AC equals half of HJ. So that is nothing but I'll have 3y minus 5 equals half of 4y plus 2. 4 divided by 2 is 2 and 2 divided by 2 is 1. So I'll have 2y plus 1 equals 3y minus 5. So further, if I subtract 2y on both sides and add 5 on both sides, I will get y equals 6. Okay, the answer is they are asking HB. From figure you can see that HB is this portion. It's going to be congruent to BJ and AC. AC is already 3y minus 5. So I can say HB equals AC equals 3y minus 5, which is 3 times of 6 minus 5. 6 times 3 is 18. 18 minus 5 is 13. So you'll have 13. Okay, let's see the last one. GH equals 7z minus 1 and BC equals 4z minus 3. Let's see how GH and BC are related. GH and BC. BC equals half of GH. So 4z minus 3 equals half of 7z minus 1. To make my work simple, instead of dividing here as these are not divisible, I will multiply by 2 all throughout. I will multiply by 2. Multiply this whole thing by 2 and this whole thing by 2. These two will get crossed out. 2 times 4 is 8. Z 2 times 3 is 6 equals 7z minus 1. Then further subtract 7z both sides and add 6 on both sides. 8z minus 7z is z. 6 and 6 will get crossed out. 6 minus 1 is 5. So you'll have z equals 5. But they are asking you to find the value of GH. GH is 7z minus 1. 7 times of 5 minus 1. 7 times 5 is 35. 35 minus 1 is 34. Is the value of GH. Okay, let's see the next slide. You have CG, EH, FJ as the bit segment. You have CG, FJ and EH are bit segment. You have CG, FJ, EH are the bit segment, and just getting this little down so that I can scroll. Okay. But it'll in this triangle GHE respectively. Find each measure. So find CG, EH, FJ first, then you can try the others. Okay, try this first. Okay. Use your chat. Once you have the answer, I'll give you like a minute. You know these are the bit segment. This is your bit segment, this is your bit segment, and this is your bit segment. So CG is going to be over here, which is going to be half of AB from your theorem. And you know AB is already 33, so 33 divided by 2, which is 16.5. Then EH is going to be half of DC, equals half of DC. Do we have measurement of DC? Yes, because C is the midpoint. We know GC is the mid segment, so C is the midpoint. If this is 22, this is also 22. So half of 22, which is 11. Then FJ is going to be half of GH. Half of GH. We know CG equals 16.5. This whole thing is 16.5. So GH is going to be half of 16.5, which is nothing but 8.25. And this is your 8.25. Okay, GH is 8.25, HC is 8.25. Then they will add to 16.5 because GC is half of AB. GH is half of GC. So this is 8.25. And FJ is going to be half of GH, which is half of 8.25. Which is I think 4.125. Let me see. Yes, it's 4. 125 in decimals. Okay, let's see the angles as well. Measure of angle DCG. They are asking us to find DCG. If these two, if GC is the mid segment, then it's going to be parallel to AB. Then these two becomes the corresponding angles. If this is 57, this angle also will be 57. So I can say GCD or DCG equals 57 degrees. Okay, let me erase a little bit for you all so that we can only concentrate on the angles now. Okay, we had these two parallel, so these two angles are congruent by corresponding angle pair postulate. Now, to find GHE, this side is parallel to this side. So once again, these two angles are congruent. Angle GHE is congruent to angle GCD. So angle GHE equals 57 degrees. Same way, we will have this line is also parallel to FJ, and these two are corresponding angles. FJE is corresponding to GHE, so this is also equal to 57 degrees. I hope this is clear. Let's see the next slide. Okay, what I'll do is, as we are running out of time for asynchronous, I will ask you to work on the review packet. I will give you a link where we have to submit the review packet by next class, and we will continue from this slide in the next class. Okay, please work on the review packet.